So welcome everybody. Thank you for joining us for this meeting. We're doing what we'd like to call somewhere in between a soft and a hard launch of the Global Snakebite Research Hub, which is a knowledge hub through the Global Health Network. We've got a pretty exciting agenda for you today. So I'll go ahead and just mention what that'll look like. So I'm going to give a quick introduction at the beginning as people join. Then we're really lucky to have Professor Warrell here, who's going to be taking some time to talk about the importance of research in curbing snakebite morbidity and mortality. Following that, we'll have a lovely presentation from Dr. Nicholas Amani Hamman and Nuhu Mohammed from the Snakebite Treatment and Research Hospital in Kaltungo, Nigeria. They'll be talking about research activities at their institution. Lastly, we'll have a talk from Dr. Frank Tianyi from the Liverpool School of Tropical Medicine. He'll be talking about the new ANYSNAKES trial and what's involved with that. So with that, thank you so much for joining us, and we will get started. Before we jump in, just a few quick housekeeping rules. This is operating as a Zoom meeting rather than a webinar, so you'll notice you're kind of in the same area as all of the panelists. We do ask if you could keep your cameras and mics off for now if you are joining just as an attendant. This will help with things like bandwidth issues and help things run smoothly. However, you can use both the chat function and the Q&A function to chat with us or ask any questions. Please feel free to do this throughout the webinar. There will be some time to ask questions kind of in between presentations as well. And lastly, there is a closed captions function at the bottom toolbar. So while this webinar or while this meeting, sorry, is not being translated, you can choose to sort of hear it in a different language if you wish through the closed captions function. So I'll take a couple of minutes myself just to introduce why we are all here. My name is Aashna. I'm a DPhil, which is a fancy word for saying PhD student at the Global Health Network based at the University of Oxford, and my research falls within the sort of intersection of data science and snake bites. The reason we are here today is because we have a new knowledge hub. So for those who may not know, the Global Health Network has more than 60 knowledge hubs. And what we mean by knowledge hubs are websites that are focused on a particular set of diseases, particular health conditions, community engagement. But there's a topic that these websites focus on, and they aim to kind of collate resources, but also connect folks who are working on those topics of interest to global health. So with that in mind, around this time last year, actually, I sent out a survey through the Global Health Network for my own PhD, just to learn about who was working on snake bites and where they were located. Through that, we actually learned there was a lot of enthusiasm for snakebite research. So despite the limited number of people working on snake bites, there was a lot of enthusiasm in sharing knowledge and best practices. So we held a series of webinars in March of 2024, just to showcase the various activities and research that were happening around the world related to snakebite. This led to the creation of the Snakebite Hub, which launched just a couple of weeks ago. So it's online now. And our coordinator, Louis, is going to pop the link to it in the chat. So this hub aims to do what other hubs do in terms of collating resources, but you'll see there's a handy tab on the hub where you can add your own name and find other people who are working on snakebite research around the world. But you can also learn about current opportunities related to snakebite, which brings us here today to kind of launch the hub and get together to chat about snakebite research. But the hope is kind of in the new year, we're hoping to have regular snakebite hub working group meetings. So you will have noticed in the registration form for this webinar, there was a section to indicate interest in joining a working group. So this will be sort of a casual group made up of snakebite researchers or those who are interested in snakebite research. We'll aim to meet regularly in the new year to again share best practices and share research updates and hopefully encourage collaboration, because that's what makes this area of research so great, is that there's a lot of collaboration going on. That's it from me. I'm actually going to pass it over to somebody who really needs no introduction. It's Professor David Warrell, who was an emeritus professor of tropical medicine and former head of the Nuffield Department of Medicine here at the University of Oxford. You may know him from massive clinical trials for antivenom and a whole bunch of snakebite research that dates back a few decades. So I'm really excited to hear of what he has to say about the importance of research in curbing snakebite morbidity and mortality. So without further ado, I'll pass it on to Professor Warrell. Thank you.
Well, thank you very much, Aashna. And I'd like to start by saying very emphatically indeed, congratulations to you, Louis, and the rest of your team. I don't know what your team is comprised of, but for starting this initiative. And of course, it's a particular delight to me that it should be here in Oxford, which, apart from a few lone voices over the years, has not been a particular hub of snakebite activity. So thank you very much, and thank you for including me in this launch. I'm very flattered to be included, and thank you and congratulations for starting this initiative. And I really hope that it succeeds. It deserves to succeed. So I've been given this title today, Why Research is Important in Curbing Snakebite Morbidity and Mortality. And there is a lot of research going on, of course, particularly laboratory research on venoms, the laboratory toxinologists, and it's important that we should know as much as possible about what snake venoms contain and how these different toxins vary within species and between species and so on. But it's also very important that there should be research on the clinical side. And I feel this is the neglected part of toxinology research. Being a clinician myself, I would argue that it's more difficult to do than laboratory work. But of course, that shows my ignorance and lack of laboratory skills. But anyway, the importance of research to start with, I mean, I'm sure you'll all agree that basing our clinical practice just on observation experience alone, so-called empiricism, anecdotes, expert opinion, common sense and fashion may sound appealing, but it's proved to be unreliable over the years. Scientific evidence based on well-designed trials is really the only reliable guidance. And all these adjectives are important here. Research must be well designed, it must be adequately powered, must be prospective, it must be randomized, double-blinded, controlled, for the most powerful support for what we do as clinicians. And placebo control, of course, is the ideal pattern if you're introducing a new treatment. But this is really only possible if there's genuine uncertainty shared by the whole medical community that the treatment is more effective than it's dangerous. And in the case of antivenoms, I think we're long past the stage where people were uncertain. I think there's, despite the lack of formal evidence, there's such an abundance of experience supporting the effectiveness of antivenoms. Ethically, it's extremely difficult to find an opportunity to do placebo-controlled trials, although a few have been done. So I'd like to just take 3 examples of research and how this research has had an impact on snakebite morbidity and mortality, and also take this opportunity to highlight contributions by some outstanding colleagues and collaborators. I've selected 3 items here. First of all, snakebite prevention, and I'm citing the example of nocturnal crate bites in South Asia and the use of mosquito nets. Then first aid, the use of pressure pad immobilization, and finally, the one that is perhaps closest to my heart, therapeutic trials of antivenom and other interventions. So let's start with these nocturnal crate bites. I'm not sure how many people participating in this launch are from the South Asian region, but even outside that region, I'm sure many of you will be aware that throughout this large geographical area, there are different species of kraits. This is one of the most important, the common or Indian krait, which bite people while they're asleep on the ground, particularly at night, and forms a very distinctive problem. There's very little local evidence of the bite. It may be painless, very little swelling, but sometimes many hours after the bite, which may not have been noticed by the sleeping victim, the patient starts developing inexorable descending flaccid paralysis, starting with the upper eyelids, but eventually involving the muscles of respiration and causing death from respiratory failure. And anyone who doubts the reality of nocturnal krait bites may well have seen this video taken in a dormitory in Bangladesh, which shows a krait entering the dormitory. Here is the krait, and it actually bit at least 2 people and killed 2 people sleeping in that dormitory. And this video, I think, went viral, so many of you may have seen it. It's really a stunning confirmation of this danger of sleeping unprotected, particularly on the ground at night in South Asia. But this problem of nocturnal bites indoors is not unique to South Asia. In Africa, I've seen the same thing with spitting cobras and burrowing asps. And in Australia, the mulga snake or king brown snake can also enter people's houses and bite them while they're asleep. So to tackle this problem, my friend and colleague Sanjeev Kumar Sharma launched a community-based study here in the southeast corner of the Tarai region, that's the flat region of Nepal. And he worked in these four villages here that you see enumerated. And he found that among 56 people bitten indoors while they were asleep in these 4 villages, only 10 had slept under mosquito nets, while the majority had slept without a net. And this produced a convincing odds ratio that sleeping under a bed net prevented bites. This, of course, is extremely good news for interventions, because there are many other reasons for sleeping under a mosquito net in South Asia and in other parts of the world. So this is the message then that has come out of this work and has been adopted on the basis of this evidence from a trial, from research done in Nepal. Another research priority in snakebite envenoming, of course, is first aid. And first aid, just to remind you, this is a treatment that should be carried out as soon as possible after the bite by the victim, her or himself, or anyone else who's in the neighborhood and who's able to help, and that implies who's been trained. This is by far the most contentious and yet the least researched area of snakebite management, and yes, it's extremely important. The principles of first aid, of course, to reassure the victim and if necessary resuscitate them, to delay absorption and systemic spread of venom from the bite site, and to make sure that the patient is delivered to medical care without succumbing in the process. So this involves arranging transport and above all to do no harm. And the work I want to cite was done by my late friend, Dr. Utung Pei in Myanmar or Burma. And he was testing a method that he'd learned from the literature from Monash in Australia, published originally by Anker and his colleagues, that applying a pad of material, Tungpei actually used foam rubber, but it needn't be foam rubber, directly over the bite site and binding it on very tightly and splinting the limb to avoid movement. He investigated the effects in a field study. And there were 2 groups of studies, patients admitted to Tianyi Hospital, which is just north of the capital Rangoon, who had evidence of local envenoming, had the pressure pad immobilization applied when they arrived in hospital. And it was found that those who had detectable Russell's viper antigenemia, this was detected by a quantitative sensitive enzyme immunoassay, which Tung Pei, who was a very gifted immunologist, had developed in Myanmar. They found that the concentration of venom in the blood remained stable as long as the pressure pad was applied. But the moment it was released, the concentration increased, indicating that the pad was effective in containing the venom at the site of the bite. In a separate study, a group of villages in the Tianyi area of Myanmar were taught about using a PPI method, and patients who arrived in Tianyi Hospital having applied PPI were checked for, again, Russell's viper antigenemia. Those that had antigenemia, again, it was found that the levels remained stable over 15 minutes as long as the PPI was in place before antivenom had to be given. But in others, antigenemia was detectable both before and it increased after the release of the bandage, of the pad. And here are some of those results. On the vertical axis is the concentration of Russell's viper venom antigens in these patients' blood, and along the horizontal as a time axis, here showing that the stability of the levels of venom antigen as long as the pad was in place, suggesting that it was restraining the venom and preventing any further release from the bite site. But you notice the way the levels of venom took off once the pad was released. And both these studies strongly suggested that the pressure pad immobilization method was effective, as well as being a great deal more practicable, more easy to apply in snakebite endemic countries than the better known Struan-Sutherland's crepe bandage immobilization method. And just to bring you up to date about the concept of the pressure pad immobilization method, imagine the venom is deposited in the tissues. This is the fang, and the smaller molecules are taken up by the veins, the larger molecules by the lymphatics, and transported into the and become systemic in their effects. The aim of this method is to compress the veins and lymphatics in the immediate vicinity of the bite, where the venom depot is situated, by compressing them. And the method is to apply a roughly fist-sized pad of any compressible material, whatever's available, immediately, because first aid, remember, has to be done immediately over the bite site. So here it's being, in this demonstration, it's a bound-up bandage, but it certainly doesn't need anything sophisticated as that, applied directly over the fang marks, bound on with a non-stretchy bandage, and crucially splinted to avoid muscular movement in the bitten limb. Now, my third example is snakebite envenoming research, the therapeutic trials. I think for me as a bedside hospital-based clinician, the most crucial lack of evidence for convincing us that what we're doing to the patients really is effective and safe. Sadly, there are very few gold standard randomized controlled trials that have even been attempted in snakebite. And this is for a number of reasons with which you'll be familiar. First of all, the demands of statistical power and acceptable design are very difficult to fulfill. I mean, the demands made in any other disease in medicine. It may be difficult to access sufficient numbers of envenomed patients within a reasonable time frame clearly your trials can't go on for years or the product will become obsolete. And finding sufficient places where the medical facilities are able to fulfill the demanding nature of modern research protocols. Snake identification is now regarded as being crucial. Really, studies of mixed snake population bites have very limited value. And national ethical frameworks, of course, are evolving all the time and are making any sort of clinical research more demanding as the years go by. And crucially, of course, funding. And I shall be telling you later, very fortunately, the funding situation has improved very much in the area of snakebite in recent years. But as a result of these problems, clinical effectiveness, safety, and dosage remain unconfirmed from almost all the manufactured antivenoms available today in different parts of the world. So I want to just take as an example a clinical trial of 2 antivenoms for carpet viper. It used to be called Echis ocellatus in the area where we worked. But anyway, carpet viper envenoming in Nigeria. And just to take you through the historical process by which this study was made possible, in the year 2000, in response to an international appeal launched in the correspondence columns of The Lancet to antivenom manufacturers to supply new antivenoms to address the shortage of antivenom for snakebite envenoming in Africa, especially by carpet vipers. It was estimated that less than 10% of Africa's antivenom requirement was being met at that stage. In response, a new antivenom was developed, known as Equitab G or ETG, by a British company, Micropharm UK. It was a sheep monospecific antivenom raised against Nigerian Echis ocellatus, carpet viper venoms, and it was developed by a very imaginative initiative launched by the then Minister of Health in Nigeria, Professor Olekoye Ransom-Kuti. You may know Ransom-Kuti better from his famous brother, Fela Kuti, author of Afrobeat, which launched me over very many miles of driving when I lived in Nigeria. And this was through the Nigeria-UK Equitab study group. This antivenom became the standard of care in Nigeria. But a bit later, another company responding to this appeal, this was the famous Institute of Colomero Picado in Costa Rica, produced a polyspecific horse antivenom against the 3 taxa of venomous snakes that were most important medically in West Africa at that time: Echis ocellatus, Bitis aritans, the puff adder, and Naya nigricollis, one of the spitting cobras. First of all, a modified phase 1 study was carried out in the form of a 3+3 dose escalation design. It was a dose-finding safety study. And this preliminary study suggested that initial doses of 1 vial of the Equitab G and 3 vials of the Equitab plus ICP might be expected to neutralize the maximum extractable venom yield based on laboratory preclinical studies. A phase 3 randomized comparative double-blind non-inferiority trial was then designed to study the effectiveness in correcting coagulopathy, which is the main life-threatening effect of carpet viper venoms, to study its effectiveness in patients with confirmed Echis ocellatus envenoming. And our principal investigator in this study was Professor Abdul Razak Habib. So the site of the study, as I've already said, the site is absolutely crucial. You have to have enough patients admitted to one or a few hospitals in a geographical area in circumstances where the medical staff are very helpful and enthusiastic. And there's more to it than that. The community involvement is also essential. And the site that was chosen was Kaltungo in northeastern Nigeria. It's a very beautiful area. This is the scene when I first visited Kaltungo Hospital in 1973. This was a former mission hospital. And here's the hospital in 1990 while we were thinking about developing this study. And this slide is rather important because it emphasizes the importance of, in endeavors of this sort, of getting full support from the community. Our crucial local contacts included the local chief, the chief of Tangali, the local religious and feudal chief in this area, and officials from the Federal Ministry of Health. This is Abdul Salami Nasidi, and here is Dr. Abubakar Bala, who is with us today. He was the medical officer in Kaltungo Hospital, and others involved from the Liverpool School of Tropical Medicine and elsewhere. So during the 9-month period, 400 patients with incoagulable blood resulting from envenoming by carpet vipers were recruited out of 1,102 snakebite admissions. So this is quite clearly a hospital that has to deal with a great deal of snakebite, and that's really why I was attracted to visit Kaltungo in 1973, because of its reputation as a snakebite hospital. Here are the results. So first of all, the primary outcome was permanent restoration of blood coagulability 6 hours after the initial dose of antivenom. So you'll see that in the 194 patients treated with Equitab plus ICP, 83% of them showed this dramatic correction of the coagulopathy within the first 6 hours, compared to 76% of patients treated with Equitab G. And very important as far as safety is concerned, both these antivenoms clearly had some adverse reactions. You'll see the rate of early anaphylactic reactions here. And but the results showed that 3 vials of the new antivenom, the polyspecific antivenom, were not inferior to 1 vial of Equitab G in restoring blood coagulability and in safety. So that's the principle of non-inferiority studies. It's rather than trying to compare superiority, you show that really two interventions are equivalent. And it was clear that at these doses, ET plus was slightly more effective, but ET G was slightly safer, but that both antivenoms could be recommended for treating carpet viper envenoming in Nigeria. So in conclusions, ladies and gentlemen, snakebite envenom is the most neglected of all neglected tropical diseases. And until recently, when its neglect was finally recognized by WHO, it had attracted little scientific interest or research funding. Now, very fortunately, the Wellcome Trust, particularly, but some other granting agencies as well, have greatly improved the funding situation. But most aspects of prevention and pre-medical and medical care still lack a convincing evidence base. The message here is there's a great deal to be done. So for the young, enthusiastic and vigorous participants in this pioneering launch meeting today, there's a great deal to be done. In particular, the clinical use of antivenoms, which are a neglected class of biological drugs, has been based almost entirely on results of laboratory tests in animals. And quite apart from the problem of using animals as test objects, they prove to be rather inappropriate models for human envenoming in many respects. So clinical trials of antivenoms and the many other exciting therapeutic agents that our laboratory colleagues are discovering month by month, these trials are urgently needed to provide the scientific evidence towards curbing snakebite morbidity and mortality. And thank you for your attention, and thank you again, Aashna, for inviting me to this very exciting launch.
Thank you so much, Professor Warrell. That was a fantastic presentation, and I'm really glad you mentioned both Kaltungo and the importance of clinical trials for antivenoms, because as we'll see, these are both going to be relevant to our next presentation. So thank you so much for taking the time today, and perhaps I can ask participants if they have any questions, please post them in the chat for now, and then at the end, if we have time, we'll discuss live. But without further ado, I see Dr. Amani is already sharing screen. I will hand this over to him. He'll be speaking on behalf of himself and Nuhu Mohammed as well, who are both leading research at the Snakebite Treatment and Research Hospital in Kaltungo. So thank you, everyone, and take it away, Dr. Amani.
Yes, good morning, good afternoon, good evening, depending on where you're watching us from. I'm Dr. Nicholas Amani Hamman, and we are presenting on behalf of the team here at the Snakebite Treatment and Research Hospital, Kaltungo. Here in our conference room is the whole team of senior clinicians, nurses, and also laboratory scientists who are engaged actively in the management of snakebite in Kaltungo. And it's a privilege for us at this end to see Professor David Warrell. Thank you very much for the work you've done in Kaltungo. And of course, what we do here is just to build on the very good foundation you, Professor Habib, and others have done in Kaltungo. Thank you very much. Well, this presentation mainly focuses on the research activities at the Snakebite Treatment and Research Hospital, Kaltungo. I am presenting on behalf of the team here in Snakebite Treatment and Research Hospital, Kaltungo. And this is the outline. I hope you're seeing the outline clearly.
Yes, we can see that clearly.
Yes.
Thank you.
Actually, this is just a picture of the current hospital now, Prof, because you showed us the initial hospital in your presentation.
Fantastic, fantastic.
That's the picture of the current hospital now. And of course, this is like this is capturing the admin block and the accident and emergency unit. And on your right-hand side is the male medical ward. And of course, the female side is actually on the back of that admin block. So you may not be able to see it clearly here. Yes, Snakebite Treatment and Research Hospital. Snakebite was organized as a public health problem in northeastern Nigeria in the 1940s, as mentioned by Prof. And the bite of small-scale viper, that is Echis ocellatus romani now, was seen as a death sentence in Kaltungo and its surroundings. And as rightly pointed out, snakebite cases were observed by Professor David Warrell at the Ahmadu Bello University Teaching Hospital in Zaria. And this experience sparked an interest, which ultimately led to his visit to the hospital in Kaltungo. And of course, his visit actually sparked a lot of research interest and enthusiasm that led to intense investigation into the epidemiology of medically important snake bites. And of course, this moves from this stage to the formation of the ECITAP study group, which Prof has already mentioned, where a lot of work was done, which led to the production of the ECITAP ICP, which is actually the most common antivenom that we use in this center. All right, the ward existed in General Hospital Kaltungo, that is formerly the SIM Hospital in Gombe State, northeastern Nigeria. However, in 2019, it was commissioned as a full-fledged snakebite hospital with a 150-bed capacity. And in that hospital, it focuses on treatment, training, and research on snakebite envenoming, which Prof has already mentioned as one of the most neglected, in fact, is the most neglected tropical disease. The hospital currently prides itself as one of the largest hospitals in the world in terms of patient loads. We see over 2,500 cases per year. So with this number, we actually see a large chunk of snake bites, of course, in this part of the world. Now, It may interest you to know that over the years, the hospital has treated over 2,500 cases, and the hospital utilizes still paper-based record system. And it also interests you to know that the records of patients from 2019 to now is intact for any form of retrospective study. And that's a total of about 13,000 patients is intact for any form of retrospective study. We are now reaching about 16,000 by now. And the facility sees patients from northeastern Nigeria, the 6 states of northeastern Nigeria, Bauchi, Gombe, Adamawa, Taraba, Yobe, Borno, and of course, from Plateau State, which is the north central part of the country, Nasarawa, Cameroon, and of course, the Chad Republics. Gombe State, which hosts the hospital, contribute about 49% of those patients, while the remaining proportions are being shared by locations mentioned above. Now, this is an overview of demographic distribution of patients seen at the hospital from 2019 to 2023. And of course, you see we've seen 13,953 patients, and with actually a very low mortality rate of around 217 patients only. And this graph shows the distribution in terms of sex. You see male patients have consistently maintained their number as the highest number of patients available in the that we see in the hospital, followed by pediatrics, interestingly, and then subsequently the female patients. Now, from looking at it from the state of origin or the origin where the patient comes from, you can see that we have out of the 13,953 patients, Gombe State contribute about 60-something% of those patients, while other percentages are shared by, Gombe State contribute about 49%, while other percentages are shared by other states mentioned, and of course the Cameroon and the Chad, the neighboring countries. Now, in 2023, we saw 2,592 patients. And if you can see clearly, this graph shows the rate of admissions for snake bites within that period of time. The peak period of that is usually in July, especially for the male patients, because it's usually the time that farms are being tilled in this part of the world. And of course, it goes down again and comes up in October when harvest usually takes place. And this different when you look at that of the female patients, we see more of them in April. And of course, it comes down again and goes up again around the month of November, when harvest of beans and granules usually takes place. In this part of the world, mainly women are engaged in planting such kind of crops for living. And of course, pediatrics actually also have a different pattern of with their peak period occurring around the month of July. Now, in this year 2024, as at the night of 30th November 2024, we saw 2,100 patients. And it may interest you to know that the peak period this time around started around April, because that was the time that people started clearing their farms in this part of the country. It went down again, and then to the time of plowing around weeding around August. And of course, the graph is still coming down. And looking at it from by sex, by age, and by states of origin, the data of patients by sex, age category actually shows a similar pattern of peak and dropping. But that of the state of origin, actually we see an interesting pattern here. This actually presents just patients from January to June 2024, where we saw 1,022 patients. The peak periods for Gombe State is actually April. That was when the clearing of farms started in Gombe State. And it may interest you to know that Taraba State started clearing their farms a bit earlier because rainy season started earlier in that part of the state. And of course, that was why their peak period actually occurs around March. And while that of Gombe State and other states like Bauchi actually maintain a similar pattern of distribution. Now, it's very, very clear from what we just presented that Nigeria has continually maintained a large burden of snakebite envenom in sub-Saharan Africa. And northeastern Nigeria, interestingly, carries one of the highest burden of snakebite envenoming within the country. And of course, Snakebite Hospital is one of the largest hospitals in terms of patient load in sub-Saharan Africa as far as patients admissions for snake bites are concerned. Therefore, to tackle this challenge of this snakebite envenoming, especially in the northeastern part of the country, there is need for us to conduct high quality research as mentioned earlier by Prof. And then we need to also see from those research findings, we can strengthen policy integrations and continually build research capacity of course, research as far as snakebite envenomation is concerned. And this, once their research capacity is built, they can easily conduct high quality research and focus on answering unanswered questions in the snakebite envenoming. So therefore, this facility has participated in so many researches, and as earlier mentioned by Prof, we've had over 30 research that are peer-reviewed and are published in international journals, and this is just a few of them. And most of those research are led by the National Snakebite Intervention Center in Kano, led by Professor Habib Adin's team. And they have been mentoring us over the years to see how we can develop our research capacity. And of course, they have exposed us to ability to conduct researches and also participate in some of those researches as the time goes on. And worthy of note is the last one, the randomized control trial to optimize antivenom therapy for carpet viper envenom children in northeastern Nigeria, where we found that there is no difference between 1 vial and 2 vials of Ekitab ICP plus in management of snakebite envenoming in children. And of course, of all those research, we've not actually sat down. We are still working day by day and seeing how we can develop our capacity, how we can look at unanswered questions. And currently, Prof and other dignitaries here present, we are conducting currently 9 research studies currently within the hospital. The first one is the improving care for the snakebite envenoming, which is focused on repurposing unitiol. And this one is being led by our team in Kano, the National Snakebite Research and Intervention Center, BUK. We are also looking at how we can leverage on advanced data analytics to predict snakebite outcomes among different cells, sex, and different age groups. This one we are doing in collaboration of the TGS, and this research is at the rate of review, and I think we are hoping to publish it early next year. And then there's also another research that's been coordinated to by our team in Kano, conducting a pilot study to explore the relationship between pesticide poisoning and snake bites. And we are actually looking at, currently a pilot study is ongoing in collaboration with our team in Kano. We're also looking at the vulnerable groups, the pediatric outcomes of snake bite. We are looking at what are the factors that influence the outcome of snake bite in pediatrics. And this research is done. We are done with it. We are already at the review stage. Of course, we are seeing the possibility of publishing it by early next year. Another thing we are looking at is one area which is actually excites us here at the Snakebite Hospital. This is being done with the collaboration with the Global Health Network. We are looking at retrospective analysis of snakebite incident among pregnant women from 2019 to 2024. It may interest you to know that this is actually going to be a very large study because we have a very large sample size. We are currently analyzing the data, and it's part of the studies that we are going to be bringing out possibly by next year, first quarter. And of course, currently there is a study which we're going to be starting within this week, and we are looking at recently a new antivenom has been supplied to us by the Federal Ministry of Health. That is the Panaf antivenom, and we are looking at how we can assess the safety. We are doing preclinical assessment, dose finding, and also observation studies for patients that are envenomed by Echis romani. This has actually been, we are under the mentorship of our seniors and chiefs here in Kano, where we are looking at what is the effectiveness, what is the safety. It's not actually a randomized control trial, it's actually an observational study because those patients will still receive the anti-snake venom. Another thing we are looking at is a tissue plasminogen antivector polymorphism and hemorrhagic tendencies. We're actually trying to investigate the relationship between the TPA polymorphism and hemorrhagic tendency in snakebite patients. This research is currently going on within the facility. And last but not the least, in the area of research, we're also looking at the epidemiological characterization of snakebite envenoming in northeastern part of the country. This is actually a very large study, which is actually currently we are looking at how we can have an epidemiological data, a comprehensive epidemiological study that will provide an up-to-date epidemiological data on snakebite envenoming in northeastern part of the country. We've actually submitted a grant application with the NHI looking at epidemiological analysis, predictive modeling, and public health enlightenment strategy on morbidity and mortality of snakebite endemic areas within the northeastern part of the country. We've actually submitted it with NIHR. Now, this is not done. The Snakebite Treatment and Research Hospital is still looking at some research questions that are still unresolved, particularly in the northeastern part of the country. Some of those things we are trying to look at and possibility of exploring, we are open to any form of collaboration, is what is the real prevalence of snakebite in the northeastern part of the country? And that is what we are trying to do while doing epidemiological clusterization. And then another issue that we've noticed that all our patients must have had traditional concoctions before coming, either they rub it or they ingest it. So the question is that what is the effect of those traditional concoctions on the outcomes and treatment efficacy in the patients? We're also looking at the vulnerable group, the women and children. What is actually the impact of snakebite envenoming among them? And also we are looking at the environmental factors, urbanization and also climate change. How does it affect snakebite behavior and incident bite in northeastern Nigeria? We are looking at it as well. And of course, we are also looking at the epidemiological patterns. We are talking about snakebite hotspots and also the risk factors, especially in the northeastern part of the country. Now, Snakebite Treatment and Research Hospital Kaltungo is open for partnership snakebite research. And here with us is the rich data repository. We have a rich data repository, as I mentioned earlier. We have intact folders that contain information of patients up to 2019, from 2019 up to now. We have expert personnel, and as I rightly, beside me is Dr. Abubakar Saidubala, who has seen over 20 to 30,000 of patients of snakebites. And of course, we have an established framework where procedures are followed to ensure that your research are protected and they are properly done as far as ethical standards are concerned. We also have young and enthusiastic researchers who are eager to participate and eager to learn and eager to be mentored. We also have a local community engagement, as Prof has just shown at a picture with Mike Kaltungo. And of course, we have a good relationship with the community, and the community is ready to participate in anything that will help. And there's also space for capacity building and development. And we also have potential for innovative solutions. Now, what are we looking at? We are looking at collaboration as research collaborations, where we look at snakebite envenoming, looking at different patients' characteristics and different hospital infrastructures. Having this thing will actually bring out researches that will produce results that can be generalizable as far as snakebite envenoming is concerned. We're also looking at provision of anti-snake venom, which is the mainstay of treatment of snakebite patients. And of course, we are open to any collaborations that will actually provide our patients with access to anti-snake venom, which is actually very difficult, especially in low socioeconomic classes. We're also looking at infrastructure development, especially research infrastructure, where we can have data that can be able to, sustainable data. All those paper-based record systems are actually obsolete in all parts of the world, but we are looking at how we can have collaboration in such a way that these things can be done. We are looking at public awareness. We can collaborate in the level of public awareness and education, policy advocacy, and other areas, of course, of mutual benefit. In conclusion, this presentation and the hospital wouldn't have been successful without a very good and well-established foundation by our esteemed leaders and distinguished authorities in the field of snakebite envenoming. But of course, their contribution has actually shaped our approach and has actually aroused our enthusiasm to participate in the snakebite research. We would like to appreciate Professor David Warrell, who is here with us, Professor Abdurazak Habib, and Professor Garba Ilyasu, Professor Nasidi, Professor Hamza, Professor Chedi, Dr. N. Durfa, my respected predecessor, Dr. Suleiman, and many other officers who have worked within the facility. And of course, Dr. Abubakar Balla, who is beside me, who has actually been here for over 3 decades now, seeing patients with snakebite. He has a lot of experience, and of course, his experience in this hospital has been enduring, and of course, source of inspiration to all of us here at the Snakebite Hospital. We also appreciate the Executive Governor of Gombe State, the Honorable Commissioner of Health, the directors, the Executive Secretary, Hospital Service Management Board, and his directors, especially the overseeing director here, the Director of Medical Services. We extend our heartfelt gratitude to all of you for your relentless effort in developing our enthusiasm in this. Thank you very much.
Thank you so much, Dr. Amani, for a wonderful presentation. I hope everyone enjoyed learning about the current and past and I guess future research activities at this institution. I think Dr. Amani nicely highlighted the patient load that they get and the absolute ideal combination of factors that this institution has to encourage collaboration. So I really encourage folks to reach out to collaborate. But with that, I'd like to pass it over to Dr. Frank Tianyi, who will talk about the ANYSNAKES trial. Dr. Frank Tianyi is from the Liverpool School of Tropical Medicine, and many of you might already recognize his name from reaching out earlier about recruiting trial sites for the ANYSNAKES trial. So I'll let him hop in and tell you more about what he's doing. Thank you.
Thanks a lot, Aashna. And thanks again for inviting me to talk about the ANYSNAKES trial. Thanks to Professor Warrell and to Nicholas for starting us off so brilliantly. And I'll try to make it quick. I can notice a few friends and colleagues amongst the audience. Thanks for coming over to support me during the talk. So ANYSNAKES is an acronym that stands for Advancing Management of Systemic Envenoming by Testing Multiple Antivenoms. And we're working on this with the MRC CTU at UCL, and it's been funded by the Wellcome Trust. I'll talk, sorry, let me move my slides. Yeah, so I'm going to mostly share a story that has two parts. The first one is about multiple snakes. In sub-Saharan Africa, there are about over 110 venomous snake species, and 24 of them are classified as being of the highest category of medical importance, meaning they live in close proximity to humans and animals, and their bites can cause death or severe injury. And as you can see from the figure by Longbottom and collaborators, the sub-Saharan African region actually has the highest proportion of these medically important snakes, and for some of them, there is no effective therapy yet. And what these multiple venomous snake species will do is that when you get a patient with a snake bite, you could have multiple clinical presentations. Professor Warrell has touched a little bit on what the venom toxins can do, but in reality, they could have either local effects or systemic effects, and they could affect most of the vital organs in humans. And besides the problem of multiple snakes, there is an issue with antivenom on the continent, which up to now is still the gold standard of treatment, and there is a lot of work on next generation therapeutics, but those will be a while before we have them being used in clinical settings. So some of the real challenges that exist for antivenoms are access and availability. As you can see from the image, there's not a lot of antivenom manufacturers on the African continent. And so most of the antivenoms that are being used come from out of the continent. The regulatory processes could be better, as well as the evidence supporting their clinical use. But at the moment, most of these have been based on preclinical animal studies with very few head-to-head randomized controlled clinical trials. A paper by Potter and colleagues in 2019 found 16 antivenoms in the sub-Saharan African market, and these antivenoms performed differently. Some work done at the Liverpool School of Tropical Medicine looking at 4 antivenoms in Kenya tested them against the medically important snake species in the country. And as you can see from the figure, the antivenoms performed really, really differently, even though they were being marketed. And this paper actually led to some antivenoms being pulled out of the Kenyan market due to concerns around their efficacy. So you can see that to run a clinical trial on antivenoms that will cover the entire continent, you will likely be looking at a lot of trial treatments or interventions. And it's unlikely that one treatment alone will serve as a gold standard across the continent. And to belabor this point, this was a paper by Sanchez and colleagues where they looked at the effect of 4 different antivenoms against carpet vipers from 3 different countries. And the antivenoms performed differently for these different snakes, even though they were from the same species. And so conducting an RCT for snakebite envenoming that's going to cover the entire continent is quite challenging. A traditional RCT design where we have one control arm and one experimental arm is unlikely to be effective because of too many outcomes and too many interventions. And so faced with this, we combined knowledge and expertise on snakebite envenoming at the Center for Snakebite Research and Intervention at LSTM with the knowledge in the design of complex clinical trials from colleagues at the MRCCTU in London. And what we concluded on was this novel RCT design called Practical. And for anyone who's interested, you can consult the MRCCTU webpage to learn more about the design. But the design has a few central tenets. One of these is individual equipoise, based on the fact that because of difference in snakebite ecology and because of challenges in availability, each patient who's been bitten by a snake at every point in time may be eligible only for a set of antivenoms. And this set of antivenoms would be considered as a personal randomization list. And so the design then will randomize patients only to this particular list. And the unit of analysis will be patients who share a personalized randomization list. And the second component is that because there will be patients across regions who would have the same randomization list, there is a possibility to use network meta-analysis approach to pool findings across different regions. And so within the trial, we'll be able to obtain direct evidence from participants with the same pattern. So you can compare pattern A and pattern B and treatment A and treatment B and treatment B and treatment C. And we can also get indirect evidence by pooling evidence across patterns. In this way, we can get an estimate of how treatment A and treatment C compare to one another, even if they were not in the same pattern. And when you apply the practical design to ANYSNAKES, what we're really trying to answer, the research question we want to know is, in patients with acute systemic envenoming, which antivenom provides the greatest probability of success, which in a study is defined as a reversal of the acute symptoms and being alive at the end of observation. And so from the trial, we're going to get the optimal treatment out of a set of available antivenoms, and these can be used in clinical recommendations. And we will also know how these different treatments or antivenoms rank against one another. For the trial, in terms of population, we will be looking to recruit adults, adolescents, and children older than 2 who have evidence of systemic envenoming following a snake bite. And we define systemic envenoming with 3 main syndromes. The first is coagulopathy based on a 20-minute whole blood clotting test at presentation. And I'd just like to say this test was first described by Professor David Warrell in 1973. He defined it then as a whole blood clotting time test. But then 4 years later, in 1977, he formalized this name, and this has been used to conduct loads of studies, including the RCT he spoke about earlier. And this specific difference between the clotting test and clotting time was the subject of our first discussion when I met David in August in Oxford in 2019. We're expecting patients who've been bitten by carpet vipers, by boomslangs, and some other snakes which can cause hemotoxicity from the trial. The second syndrome we'll be looking at is shock persisting despite administration of a weight-dependent fluid bolus. And we're expecting our large vipers, specifically the puff adder and the gaboon viper, to cause this kind of envenoming syndrome. And the final syndrome we'll be looking at is neurotoxicity, and we're expecting this from our members or our neurotoxic cobras. Local envenoming alone will not be a condition to be enrolled in this trial. And we're looking to get 1,000 patients with coagulopathy, 1,000 patients with shock, and about 100 patients with neurotoxicity. So currently, we are at the site feasibility assessment phase of the trial. And as most of you must have seen, we got in touch with Aashna to help contact clinicians who are working in hospitals where they see a significant number of patients to consider whether these could be potential clinical trial sites. And I'd like to thank everyone who's gotten in touch with us since then. There are ongoing conversations. And if there are still a few people in the audience who work in an area where they get upwards of 50 snake bites a year, please do get in touch. The feasibility assessments, usually we would shortlist a number of hospitals based on surveillance data. In most countries, it's been based on the DHIS2 reports. We're also using publications, anecdotal reports. We're talking to colleagues, and we're hoping to benefit from the large network of snakebite enthusiasts, which is the Global Health Network. The countries in green are areas where we're considering potential clinical trial sites. In amber is where we're looking to visit over the next few months. In red is where we're thinking of visiting, but the areas that are missing, if the colleagues on the call who think that they could fit the criteria, I've already had preliminary talks with Nicholas, but if there are other colleagues on the call who think they could fit this call, please do get in touch and we can discuss further. I'd like to thank the rest of the ANYSNAKES team. It's quite a long list and it's bound to grow for a trial of this nature. And we are hiring for a clinical research associate. So if anyone is interested and they have a cell phone handy, you can scan the QR code or you can send me an email and I'll forward you the link for the job role. Thanks, Aashna, and the Global Health Network for this opportunity. And I'll stop here.
Thank you so much. Yeah, and I do encourage folks to get in touch with Dr. Frank to learn more about the project. I see someone else from his team, Francesca, has also put something in the chat. So do get in touch. There are really exciting collaboration opportunities through this trial, but as well as with Dr. Amani at the Snakebite Treatment and Research Hospital in Kaltungo. So with that, I'd just like to wrap up with a quick slide just to show, we didn't show this at the beginning of the presentation, but hopefully everyone can see it now. This is a quick map just to show where everyone today is coming from. We can see there is a massive, massive representation from Nigeria. So thank you for all the enthusiasm over there. And thank you all for joining today. On the next slide, you'll see a QR code. As Frank said, if you have your phone handy, please do join the Global Snakebite Research Hub. There's also a handy link at the bottom, and do visit. This is just the first of what we're hoping to be regular meetings in the new year. So to keep an eye out in your inboxes, I'll be sending in a follow-up email in the coming weeks to kind of explain next steps and what to do. So with that, thanks everyone for joining, and a huge thank you to Professor Warrell, to Dr. Amani, and Dr. Frank for joining us today as speakers. We've been very, very lucky to have you speak. So thanks everyone, and have a great rest of your day.